This video is about ergonomics. Ergonomics, firstly, it would be good to explain the definition of what ergonomics is. So ergonomics is basically the study of the man-machine interface. Now, if we imagine that any product could be considered a machine, so let's say a cup is a machine, for example, a pencil is a machine, and the interface is our relationship with that machine, with that cup, with that pencil. Okay, so the study of how we interface with that product is the man-machine interface. It's how we use that product. Now, ergonomics is making sure basically about three things. Okay, we want to make sure that our product that we're using is safe to use, our product is comfortable, and our product is basically easy to use as well. It makes sense. It's understandable. Okay, now, ergonomics, if we want to make things easy to use and comfortable to use and safe to use, okay, is often linked to the study of anthropometrics. Now, anthropometrics, big word effectively, but if we break it down into anthro and metrics, okay, anthro is humans, okay, so the first part of the word, anthro, humans, and metrics, the second part of the word, is measurement. So anthropometrics, man measurements, or woman measurements, I suppose. Okay. Now, what people do if they want to make products ergonomic or easy to use, effectively, and safe to use, okay, they'll take various measurements from people's body shapes, body parts, effectively. So if we're making a cup, the measurements we'll probably take are probably from the hand. Okay, we'd also take perhaps measurements from where you'd also interface it, which is obviously putting it to your mouth. So you might be measuring or taking appropriate measurements from lips and things like this to make sure that when you put the cup to your mouth, it's comfortable and it's safe and easy to drink from. And also when you handle the cup, when you pick it up, when you place it down, when you open the lid, you twist it open, you close it, okay? These are all easy and safe to do as well, okay? So as well as measurements of, like, if we talk about metrics in terms of size, so actually taking millimeters, centimeters, that sort of thing, that sort of unit when we're measuring things, they could also be measurements of actual strength as well. So if we're thinking about the turning force required to put the lid on a cup, or the ability to be able to flick a lid of say a travel mug open, for example, so that it's easy to do. Okay, these sort of strength measurements are also ergonomic considerations that we need to take into account, bearing in mind the anthropometric data we've taken into account as well. Okay, so the other thing we need to think about is obviously the consumer target that's actually going to be using the product. So anthropometric measurements will vary very much from person to person. If I'm making a cup designed for a child, the measurements that I take from their hand or their strength measurements are going to be very much different to those of a grown adult, a grown female, a grown male. Okay, and this is where the measurements will change greatly. If we talk about the area of fashion, for example, or clothing, you can already see there's so much anthropometric measurements being taken into account in terms of the sizing categories for clothes. So if we've got a size 6, a size 7, an 8, a 9, a 10, or whatever, or if we talk about shoe sizes, they've taken these anthropometric data and they've made them fit these consumers quite specifically. Okay, now, the next thing to kind of think about when we're taking these measurements is percentiles, okay? So in anthropometric measurements, we talk about the 5th percentile, the 50th percentile, and the 95th percentile. So what they'll probably do is take a group of people, let's say 100 people, okay? And they'll take measurements from these people. Now, what we'll generally consider, if we want to make the product kind of fit an average, we'll be looking at the average measurement. So this is the measurement that most people fit into, okay? So if we talk about, say, shoe sizes, the average size for a male may be, say, a size 7 or a size 8, okay? So that size 7 or size 8 would be the 50th percentile. It's the where most people would fit into, okay? Now, if we go down the spectrum a little bit, so if we go down to the 5th percentile, these people might be a lot smaller smaller or a lot weaker or a lot lighter than the average person, okay? So they will be right down the low end of the category. There might be a size 1 shoe for an adult male or something like that, which is quite small, okay? Now, we might want to consider these measurements, though, when we're making certain products that we need to cater for everyone. So if we're talking about maybe the height of a chair, we don't want to make it so the smallest people cannot reach the height of the chair, okay? And similarly, on the other side of the spectrum, the 95th percentile, when we're talking about particularly large human beings, okay, if we was designing something like a door frame, we don't want to make a door frame just 5'8" high, okay, the average height, okay, because anyone who's taller than that, which is quite a large group of people, we're talking about 49% of the population perhaps, okay, they're not going to be able to fit under that door without bending and scooping underneath it. Now, I'm talking about 5th to 95%. Well, what about the people who are in the 1 to 4 or the 96 to the 100%? So we're talking really, really tall people perhaps, or really, really small people. Well, unfortunately, if we talk about the most products, okay, these people are just not catered for very well, okay? So if you take an example of perhaps a basketball player, you may find even though the average door height is aimed at very tall people, about 6'6", maybe even 6'8", they still might have to bow their head if they're maybe 7 foot tall to get under that door, okay? Or, for example, if we're talking about a very, very small person and they're sitting on a chair, for example, you might find their legs do not reach the bar at the bottom to actually comfort themselves, or they might have struggles trying to lift themselves into the chair itself. And obviously these groups are called special groups, okay? They might be specially catered for, and that's why there's sort of so many sites where you can buy sort of specially tailored clothes for particularly large people, or indeed particularly small people as well, okay? Other examples of special groups might be, for example, the disabled or the young, okay, where they have very specific requirements and they don't follow the path of the sort of the norm, or the 50th percentile, or even the 5th to 95th percentiles, okay? So it has a huge impact on the design, okay? Now, obviously, the other thing that we need to think about with these special groups is the fact that design can be inclusive or exclusive, okay? So if we're going to only make it for a certain group of people, this 5th to 95th percentile, okay, we're going to have to make sure that our design is, or it would be exclusive effectively, is excluding out those other people. If we want to make designs more inclusive, okay, if we take the example of, say, a wheelchair user, and we want to make our building or our rooms more inclusive, we have to make changes to that room to make it more applicable, okay? Examples of this might be the fact that we might have a wider door so the wheelchair can easily pass through the door. We might need wider corridors to move the things around. We may need ramps instead of stairs to ensure that they can get to different floors, or lift access. We might need that light switches and pull cords and things like this that you use on a regular basis are within easy reach of the average wheelchair user, so a seated user, okay? So these are very important criteria if we want to make designs inclusive. And various other special groups, like people with maybe special diets in food technology, or if we're talking about people who are maybe hard of hearing or hard of sight, okay? There's lots of different changes that would need to be made to products or their environment to ensure that products can be, as I said, ergonomic and therefore easy to use, safe to use, and comfortable, obviously, when they're actually using it over a period of time. Now, the final thing I'm going to discuss today in terms of ergonomics is the concept of working triangles. Now, this comes up most frequently in the environment of a kitchen, okay? So in a kitchen you have three kind of major areas. You have a sort of an area where you are preparing food, an area where you are cooking the food probably, and the other two areas would be the obviously where you collect the food from, maybe a pantry or a fridge, and the area where you are washing or sort of disposing of waste food and things like this, okay? So these three main areas, the preparation, the collection of the food, and the washing or the maintenance of the cooking equipment and stuff like this, okay, form 3 points of a triangle. Now, the idea of a working triangle is that these should be spaced out at a suitable distance for each other to, again, ensure ergonomics is adhered to, so it's comfortable, it's safe, and it's easy to use. If we make the points of the triangle too far away, we make the idea of maybe preparing a small snack a very arduous task. And in fact, studies have shown that in certain restaurants where they haven't considered working triangles, people or chefs walk miles and miles further because the repeated process of walking to a fridge and taking an item from a fridge to a preparation area and taking a pan from a preparation area to a washing area, for example, make the job very, very difficult. Okay. Ultimately, as well, if we bring the points of the triangle too close together, it will have the adverse effect with all people working on top of each other and it becoming very difficult to be efficient. Okay, so there's a brief summary of ergonomics, and obviously we've also discussed anthropometrics, percentiles, inclusive and exclusive design, and working triangles.